Today we are going to discuss about this problem and the solution using BioPython. Now you can see uh, the first question. What is saying that suppose there are three sequences ACGT, AACC, and GGTT are given. So you need to concatenate this using uh, BioPython and for loop. So is this screen visible? I think you can see that.
Yes, sir.
All right. So now for that, what you need to do? Obviously, you are going to use the sec object from the bio.sec module. So you need to write the first line as what we have written in the last class from bio.sec import sec, right? Now, next what it is saying that you need to concatenate these sequences. Okay, so that means if you are going to use for loop, so obviously for loop is easier to operate on a list element. So you can take this given sequences in a list, right? So you can write one variable where the sequences will be stored in the list format, right? So by this square bracket and using this notation sec within bracket, within parentheses, within double quotes, these sequences. So you are by this way you are making a list of the elements given sequences, right? So which is now in this list of sequence, right? So next, what is your aim? Your aim is to concatenate these sequences. So that means that concatenation element can be anything. You can add this by any kind of symbol or any kind of thing. Here it is saying that just normal concatenation, right? So that means there will be no space in between these sequences, right? So what we are doing for that, we are taking one variable and we are defining that by which element all these small sequences will be concatenated. And here we are not specifying any sequence, we are just pressing two quotes. That means nothing will be there inside that quote. Okay, so we are writing this in a variable. Now our aim is to join these elements. So obviously we need to write for loop by this way for s in this list of sequences, right? And next, what is your aim? That concatenated part, that means this one, that means this concatenated part to be repeated multiple times, right? Concatenated will be added by this each of these elements, right? So we have used this thing when we have done for loop multiple times. And after that, if you go back to the block from that block and write print that concatenated. Okay. Now we are trying to print that updated value of concatenated. So let's run this. And you can see that ACGT, AACC, GGTT all are merged by nothing. And that's why it is a concatenated sequence. Now, if you want to join this by any kind of spacer or any kind of other symbol, so that is also possible. Okay, that is also possible. Suppose you want to join this n 5n. Okay, if you write this, so you can see that n has been concatenated at the first. and then all the sequences have been merged. Okay, just a second. Okay, now you can see that it is taking that concatenated part first, and then whatever is there, that is concatenated out, right? Now, so this is not a good idea to do that. In this way, you will face some problem to add some spacers between these sequences, right? Just let me cross check what is going on. Yeah, okay, it is running. Now, to do the next thing, that is, you need to concatenate all these sequences by a spacer. So for that, you can easily do that. The same thing, same sequences have been given in a list, and now you want to join these things by a spacer sequence, right? So if you write this, that by which these sequences will be getting joined, so you are mentioning that 10 n's, so n multiplied by 10, that is your spacer sequence. And now if you use join operator, so what you will write, spacer dot join, what it will join, these contigs, these elements from this contig. Now if you run this, you are getting that it is showing that ATG, ATCC, what is going on? Okay, ATG, ATCCG, right, and TTGCA. Fine. So these three sequences have been joined by this. So if you don't want to see this sequence object here, so you can print that thing, and you are getting the output. Okay. So by this way, you can concatenate, or you can concatenate multiple with multiple other sequences as well. So that is the first example. Now second example, it is saying that you need to take one user input. Obviously, you are going to use the same sequence module from bio.sec. So every time you need to write this. Okay. Now, hopefully, you have already seen this thing, how we can take one sequence input by this way. Okay. Now, we need to put this input sequence inside the sec object to fit it with this BioPython. So what we can write, we can write this. So you can see that every time we are using this sec object. So here also we have written sec object, and within parentheses we are passing the entire sequence which we have used from the keyboard, right? So input sequence we have placed here. Now you can print the DNA seq. Okay. Now if you run this, what you will get? What you will get? Can anyone tell me? If I run this right now.
Whatever input is given.
We have not given any input, right?
No, sir. I mean, it will take the input and it will print it.
Right, right. So that means it will create a box, enter sequence, or create a terminal if you are using any other kind of ID. So there you will find that one cursor is blinking. That means you need to type something, right? So suppose you are taking the input, you are typing something. Okay, so you have I'm taking the exact sequence, so then it will be easy. Okay, so this sequence you are taking. This sequence you are taking as input sequence. Fine. Now, if you are pressing enter, that DNA sequence has been printed, right? That is printed. Now, the second part is saying this is not a question actually. You are checking that whether it is taking or not, whether the sequence is right or not. You can check that whatever you have entered that is printed. So that means the code is running. Now the question is saying that check that TATAT sequence is present or not. So for that you can use simple formula. That what is that formula? What is that method? TATAT in DNA underscore seq. If you write and run again, it is asking the sequence. So it is saying that false, right? So that is your answer. That it is checking that whether it is there or not. Okay, so what I can do, I can take this out. Anyway, I'm writing this now. Now I can change this thing. I can take any one part from here to cross check that whether I have written the right code or not. So I'm placing that thing, cross checking that. So in operator is working on this. So it is searching for this sequence in the long DNA sequence what we have entered right now, and if it is there, so it is saying that it is true. Okay, so let's check once again. Now we are checking that it is true, but if we are pressing TA AT and then run, it is saying false. So that means it is not present in this given data. By that way, you can cross check that your code is working or not. Okay. Next, it is saying that to make a reverse complement of that given DNA sequence. Now, from the basic molecular biology knowledge, you know that what will be the complement sequence of this, because this is one strand, right? Now, if you are trying to find out the reverse complement of that given sequence, so what we need to do in coding? So if I am saying, okay, so you find out the reverse complement of this sequence, TATAT. So I think you can do that. Can anyone tell me what will be the reverse complement of this sequence? TAT. Anyone?
ATA.
Okay, so I'm writing down that what you are saying. Can you say once again? AT?
Reverse, reverse complement.
Yes.
Then it will be AT,
Hmm.
TA, TA.
TA, TA. Okay. So we will check that whether you are saying that correctly or not by writing a code. So what we can do that? So obviously, if you are trying to use the same module, so we need to write this. Then we need to take that particular sequence, right? So in that case, what is your sequence? That is TA, TA, AT. Okay. Now you can check that what is your sequence now. My sake, you can print that. So you are getting that. This is the sequence. Okay. Now you are trying to fetch the complement sequence of it. So in BioPython, you don't need to do anything. You don't need to write any code. You just write complement. Okay. Now if you run this, you are getting that this is your complement sequence, right? So in place of T, it is A. In place of A, it is T, and like this. So it will be more clear if we print MySec first and then print this. Now you can check that this is the complementary strand of the given strand, isn't it? Right? Now, what is our aim? Our aim is to find out the reverse complement. So the code needs to modify something more. So that is MySec dot reverse complement. Okay. Now you are getting that ATT ATA. Whatever he said, that is the correct answer. All right.
Sir, reverse complement is a different method, or reverse and complement are two different methods, and we are able to join it in BioPython.
No, in BioPython, you need to write this syntax reverse underscore complement. Okay, then only it will work. If you try to modify this like this reverse complement, it will not work. Okay, so this is the syntax. You need to follow this method reverse underscore
No, sir,
complement.
I'm asking is what is if we use, I mean, is there a function called reverse, only reverse?
Uh, that I need to check. Wait a second. I am checking that whether it is available or not. So if you are trying to write this only, so it is saying that no attribute reverse. Okay, so
Okay,
there
sir.
is it will not work. Okay, and if you are not, if you forget somehow, if you forget this thing that you need to write a reverse complement, so then what you can do? Then what you can do? How you can identify the reverse thing?
colon operator.
Right. So then you need to use that colon operator, colon -1. So then it will be the reverse complement. You need to do this complement part, and then you can use uh, colon -1. So by that way you can do the same job. Okay. Now, if I am asking you, or anyone is asking you, that find out the reverse complement of the given amino acid sequence, so will it work? Suppose it is saying that find out the reverse complement of this given amino acid sequence. Will it work?
No, sir.
Okay, let's check.
I think we have to write the corresponding codon that codes what that amino acid, and then it could work. I don't know.
So
Right.
wait for a minute. So suppose we have written the same code, and we have written this, instead of this TATAT, we have written this. Now we are running this. Okay. Now you can see that something is there. Okay, something is there. But do you think it is a good thing?
Sir,
Yes.
where did we get the output number 26 sequence EBYNTM?
Right. Right. That is my point. Where from we are getting this thing? Right. So there is a dictionary for each of these one letter code. Right. So there is a dictionary which is called IUPAC nomenclature. So from there they have formulated something. Some amino acids are coded by one letter symbols like this. Okay. And not only that, that each letter can be corresponding to few other letters as well. Okay, that is a table like thing. You have seen that genetic codon like this, and so there is a table like IUPAC table nomenclature. Now, using that nomenclature, they are trying to get that what will be the complement or reverse complement of these sequences. Okay, by that way. But you know, the concept is wrong, because you cannot get any such protein sequence complement or reverse complement. This is only possible for DNA sequence, isn't it? As you are using the same module which is dealing with sequence only, so you are getting some values, okay, from the sequence table, but it is not a good idea. It is not theoretically right thing. Okay, so the question may be wrong, or the one who is asking this type of question may be trying to make you puzzle. Okay, so then you need to say that uh, even if we are getting some results, so the theoretical it is not possible, because we can only find out the complement or reverse complement of a DNA sequence, or we can do that on RNA sequence also, but we cannot implement this on protein sequence. Got it? Okay, so last one. Suppose the sequence is coding strand. Now, okay. So what was the question? This, whatever you have entered. Okay. So um, suppose when you are entering this thing, okay, I am running this thing again.
So can you please repeat what you said about the IUPAC nomenclature? I mean, amino acid, why we cannot
Okay,
do.
so I am saying that there is a dictionary kind of thing for this one letter code. Okay, that is known as IUPAC system, IUPAC nomenclature. Now in that system there are certain sequences, say for example V, okay, capital V, which can mean either A or C or G. Okay, and this V has a complement of B. So this kind of dictionary is already there for dealing with such sequences. All right. So as we are using the same sequence object, which is dealing protein and which is dealing uh, DNA or RNA sequences, that's why you are getting such kind of output. If even if you are trying to get the complement or reverse complement of a protein sequence, right? But that is not theoretically true. Suppose you are getting one sequence of protein, and can you really extract the complement of that protein amino acid part? It is not possible, right? Because one amino acid will interact with which amino acid, that you cannot uh, exactly predict, right? Here we know that A will pair with T, G will pair with C, not with A or not with other molecule. So that's why we can easily find out the complement of DNA sequence. But in case of protein, one amino acid can interact with many other amino acids, isn't it? So,
Okay.
so there is a problem for prediction of such kind of complement in for protein sequences. That was my point. All right. So next is we are trying to get one more example with this. Suppose the same sequence you are taking as input. Now, mm, oh, mm, now by mistake, sometimes your caps lock is on and caps lock is off condition, and you are typing. So by mistake, you have entered your data like this. Okay. Now you are trying to find out that whether TA TAAT is there or not. So obviously it is saying false because exact match is not found. So that's why it is giving you output false. But you can see that there is a TAAT region, right? So to avoid such situation, what you can do, you can make your entire entered sequence into either capital letter or whatever letter you want to use here. Okay, suppose you know that you are going to test for capital letter, so you can make this as upper. Okay, now I am taking the same user input. Now you can see that it is saying true because now it is exact match found here, TAAT in capital letter. So that's why it is saying true. Okay, so you need to check that one also. So whether the given sequence is uppercase or whether you are testing for which part that is in uppercase or lowercase, that you should uh, look for. Okay. So we are coming to the last one. Okay, so now whatever sequence you are entering, that is your coding DNA. So that is given. Say for example, this part. Okay, this part your coding sequence, right? Now suppose this is your coding DNA. You are entering from the keyboard and you are printing that thing. This is right. So this is your coding DNA, right? So you can write this DNA sequence as coding sequence. No problem with that, because it is given in the question that suppose the sequence is the coding sequence. So entered sequence is the coding sequence now. All right. Now what will be the template DNA? Can anyone tell me from the basic biology knowledge? What will be the template DNA for this coding sequence?
Complement.
Only complement?
Sir, it depends upon how we are seeing it. If we are seeing it 5 prime 3 prime and if it both it is aligned in the same direction, then it will be reverse complement. If
Right.
not, then only complement.
Right. So usually in bioinformatics job, we need to do the reverse complement of the given DNA template. Okay. Sorry, coding sequence. Suppose this is a coding sequence. So to get the template DNA, we need to do the reverse complement. Okay. So if we run this template DNA, sorry, no, coding. Okay, code sequence we have used. Now we are getting this template sequence. Okay, so this is the coding DNA and this is the template DNA. Okay. Now what will be the mRNA? So mRNA will be transcribed by coding DNA. Usually, that is the concept. So we can write this coding sequence dot transcribe method. And now if you print the messenger RNA, you will get that RNA of this coding sequence. Only you have used transcribe. You have not written any other code. So you are going to utilize the already built code which is written in this method dot transcribe. Okay, and that is being operated on this coding sequence. So that's why you are getting the messenger RNA. Okay. So we have completed the transcription part using BioPython. So next class we will complete the translation part also. Okay. So we can find out the sequences of amino acids given from a DNA sequence. That is the translation part, right? So that kind of job we will see tomorrow. Okay. Is there any question? all these are very relevant to you. All of you are biology background students, so biotechnology or microbiology or genetics, everyone is doing such things. I hope so, right? So if you find any kind of difficulty to understand this basic logic, you can ask me. You can ask me now, or you can ask me in the next class also. Okay. Any more questions? So you try to write your own codes with small uh, examples like this, so you will better understand this topic, how it is working. That much I can say. Okay, so today's class time is over almost. So we can leave. All right. See you tomorrow.